This is building on yesterday, right? And we learned about proportional and not proportional. How do we know it's proportional? What was special about proportionals graphs? What do proportional graphs look like based on yesterday? If it's a proportional graph, what is it going to look like? Look back at yesterday if you have to. The in-class activity 4. That you already did. What do the graphs of proportional look like? What do the graphs of proportionals look like? We talked about it yesterday. In class activity 4 that we did together. So what do the graphs of proportionals look like? Straight lines. Does it always have to start at 0 though? Does a proportional have to start at 0? No. Okay, it just has to be a straight line. So the graphs look like straight lines. What do the tables look like? How do we know the table is proportional? How do we know a table is proportional? Well, they'll all have patterns, but look at how, remember we talked about it on the very last question, yesterday's notes. What was so special about the tables? They both have patterns, but the proportionals pattern works with one math operation, but the others don't. What's the math operation that proportionals work with? The changes happen how? Look at the very last question on yesterday's notes. We spelled it out in words. So what was so special about the yesterday's proportional table? Go look at the last problem on our in-class activity 4 that we did together. That if you were absent, you would have done using the video. Why were we saying that the part A was proportional? What made A special yesterday? Come on, guys. I had hoped that we would get out of class early today, but not at this rate. Not if you're going to sit there and not participate. Everybody's grades drop in. The same values being added over and over. Thank you, Madison. Thank you. So if we're adding the same thing over and over, then we are proportional. Okay. Now, if I add the same thing over and over to 6 plus 6, 6 plus 6 plus 6 plus 6 plus 6 plus, If I keep adding the same thing over and over, what's a shortcut way to do that? What's a shortcut way to add the same thing over and over? What's a shortcut way to add the same thing over and over? Not timesing by 2, but multiplication. So multiplication of the same number. So yesterday we saw on number 1, 17 times 2, 17 times 3, 17 times 4. It was the same number over and over and over, okay? So remember, multiplication of the same number over and over is the same thing as addition of the same number. So let's look at how this one works. We're going to mark up, change to a color that will highlight. Doug regularly mows his neighbor's lawn. Last month, Doug's neighbor paid him $55 for 6 hours of mowing. Okay. So 6 hours, $55. And then it's asking, is this situation proportional? How do you know? So, and then it has us make the table. So when we're reading something and it tells us this amount for this time period or this many people or that many things, that is a proportional situation. So this is a proportional relationship because he is being paid the same amount for, I got to change this up, put you here, each hour of work, right? We know that we would not go ahead and be paid $4 for the first hour and $17 for the second hour and $25 for the third hour. They wouldn't do that. When they say $55 for 6 hours, that means he's getting the same amount for every hour. Same amount for every hour. And we're going to figure out what that is. So we're going to go use our equation box. And we're going to do 55. Let me make this bigger. I can make this one bigger. There we go. Too big though. Let's go in between. Because we want to see the table too. 55 divided by, so I go get my divided by symbol, 6 equals. And then we're going to go use our calculator. Someone use your calculator. What is 55 divided by 6? Someone use your calculator. What's 55 divided by 6? I don't know. Let's go look. Let me see my calculator. I'm going to share. Oop, I didn't turn my calculator on. I got to turn it on first. So, switch sharing to the calculator. Okay, we're talking about money. So 55 divided by 6. Now, how does our money work? How many decimal places does our money have? 2. So we have to look at the third spot to see how we're going to round this money. We're going to look at the third spot to see how we round the money. So the third spot is what number? What's the third decimal over? What's the number in the third spot over? A 6. Is that 6 going to make us go up or stay the same? Do 6s make us go up or stay the same? Up. So it makes the one next to it on the left go up. So how much is he making each hour? $9.17, exactly. So let me switch back. So he's making the same amount every hour because that's just how our working works. We wouldn't go ahead and get paid different numbers for each hour. Don't need this open. I need to go back into it though. Oops, dot, undo, equation. 9.17. Now it will not let you do the dollar sign in there. Okay, but we are going to add to this. He is making $9.17 every hour. Okay. And we know it's that, and we know it's proportional because it says for 6 hours. Anytime there's an each or a per or a for, those kind of things, whenever we have that happening, it's a proportional. When it's per hour or for each hour or anything that's like that. Okay. All right. So make a table that shows what Doug earns for the various hours. Okay, so we know how much he earns for 1 hour. We just did it. Oops, text box. We said $9.17 for how many hours? Click twice, 1 hour. Okay, let's do another one. What about for 3 hours? What are we going to do to find 3 hours worth? What are we going to do to find 3 hours worth? Remember, you are graded on participation, and the more you don't participate in the chat, the more you don't get participation scores. So what are we going to do? 917 times 3. So someone please go use your calculator and do that. 917 times 3. How much do we get? $27.51. Thank you. How about if we did 12 hours? Or let's do 12 hours last. How about if you did, no, we'll do 12 hours now. How about if you did 12 hours? What's he getting paid? So think about what we already know and how we could solve this one. Yeah, we would put 27.50 because of the rounding. You're right. Because we rounded this to $9.17 when it was $9.16, blah, 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 right? So we would have to go ahead and round down 1 because of the fact that we did a rounding up. Whenever we have enough, we would be rounding back down. Because I'll show you with the calculator what I mean. It's easier to show. We have this in our calculator. If I times that by 3, see, it rounds us. So whenever you're doing these problems like this where you've had to round, leave the stuff in your calculator so you can go ahead and just leave that number in there and say, okay, now times 12. Okay, so leave them in there so you can be using them over and over. But we had to round for the very first one because we had to go ahead and say our hourly rate. Okay, so 110. What about 15 hours? What about 15 hours? What did I say we would do? Go to the calculator, use our answer for 55 divided by 6, and then multiply it times 15. So what are we going to get? What am I going to get? Yep, 137.55. Okay. And I'm going to write a text box over here about what we did so we can keep track. First thing we did was this 55 divided by 6, right? Right? That's our first thing that we did. Then we use that one's answer before it gets rounded and did that answer. So it was a 9.16666, right? It was doing this times the 3 hours. Got us the 27.50. Okay. Now notice to move this, I grab this little X and I just move them to where I need them to be. So I can move my equation boxes just like I can move my text boxes. Okay. And then we use that answer again. So I'm going to use them again. But the next time I went ahead and did times 12 and got the 110. And I used it again and did the times 15. And got the 137. Okay. So yes, I want you showing me your work on where you're getting your numbers from. It was 137.50, right? Not 55. Let me fix this. Okay, so you are showing me your work. Where are you getting the numbers on your table from? Yes, you are using your calculator to get the actual number, but you have to write on the paper what it is you did in the calculator. Okay, are we clear? Yes, I'm using the calculator to get me the final answer, but I have to write what I put in the calculator so I know where it came from. Okay. Johnny brags that he gets paid more than Doug to mow lawns. Johnny gets paid according to the graph at the right. Who gets paid more and how do you know? So the way we're gonna, is Johnny's relationship proportional or not proportional? Is Johnny's relationship proportional or not proportional? It is 55. 137.55. You sure? 55 divided by 6 times 15. It's 50, not 55. Remember, we don't use the rounded number. We use the decimal number. That's why when you see my work right there, right? You see that I did not use the 9.17. I used that decimal answer from this. So let's adjust this one to go 9.1666667, which equals 917. So then it reminds you, where is that long decimal coming from? Okay. So it should be 137.50 because we're using our exact number, the long decimal, not the rounded number. So when you do your calculations, you need to be using the exact numbers, not the rounded numbers. That's why you leave it in the calculator. So let's ask again. Is Johnny's relationship also proportional? Is Johnny's relationship also proportional? How do we know? So we started this lecture talking about what the graph would look like. So is Johnny's relationship, which is this graph, is that proportional? Yes. So yes, Johnny's relationship, yes, we're putting this in too, is proportional because the graph is a straight line. Okay, that's the start of it. So now we've got to look at, is Johnny really earning more? So to do that, we have to go find where the graph is going through the exact corner where the two lines meet. See how this point right here is not going through the corner of a square? And this corner, this is not going through the corner of a square. But I do see that this one is right on the corner of the square. So we need to have our line going through the very corner of a square. That is the point we're going to look at. That is the point we're going to go ahead and find out what its coordinates are, because that's going to tell us our time and our money. Now, this one also goes through the corner, way up here. You can use either one, but you cannot use any of these that are going through the side of the square or through the edge of the square. It has to make sure it's going right through the corner where the four squares meet. Okay, and then we go get its coordinates. Now, remember, we read our coordinates, the X first, then the Y. So the left and right first, and then the up and down. So this is my dot, right? It is, nope, not going to use that. I just realized I could use this line feature. And I am going to use the line feature in a different color. So I'm going to figure out how far left and right I went by just going straight down and looking what the number is. And I'm going to figure out how high up I am by looking exactly sideways to see what the number is. Okay. Because how far over is my first number for my coordinate, and then how far up is my second number for my coordinate. So parentheses, how far over did we go? How far over did we go? Look to see where the line touches. Where did the line touch down on the bottom? That's how far over we went. How far over did we go? Four, comma. How far up did we go? Where did the line touch? What would that be? What number? 50. So this is saying that Johnny gets paid $50 for 4 hours. That's what that's saying. Okay. So Johnny was paid $50 for, one moment, I'm going to move this down, for 4 hours. Now, we look again. What was Doug paid? 55 for 6 hours, right? And Johnny's getting paid 50 for 4 hours. So who gets paid more? And when they say who gets paid more, who's getting paid more for each of their hours? What would be a bigger number? Dividing 55 by 6 or dividing 50 by 4? What's going to get us a bigger number? 55 divided by 6 or 50 divided by 4? Figure it out. Use your calculators. Come on. All this not chatting in the chat is getting people lower participation scores. You must participate if you want that full score. Which one gets you a bigger number? 55 divided by 4, or 55 divided by 6, or 50 divided by 4? 55 divided by 6, or 50 divided by 4? So we need the whole statement on which one is bigger, the 55 divided by the 6 or the 50 divided by the 4. Which one is a bigger number when we do that? $55 divided by 4 is a bigger number. So Johnny gets paid more than Doug. We're answering their question because 50 divided by 4 is greater than 55 divided by 6. Okay. All right. At what unit rate do Johnny and Doug each get paid? So we figured out Doug's, that was the 55 divided by 6, but we haven't figured out Johnny's yet. So let's go get Johnny's. What is the 50 divided by 4? What does that equal? What does the 50 divided by 4 equal? What does the 50 divided by 4 equal? $12.50. Ooh, he gets paid a lot more. Okay, so now we're going to go do the text box to answer. Doug is paid about $9.17 for each hour, and Johnny is paid $12.50 for each hour. Now, why did I say about for Doug, but not for Johnny? Why does Doug have an about, but a Johnny does not? Why did Doug have to have an about in his, but Johnny got to just be the exact number? What did we do with Doug's number to come up with 917? We had to round it. So that's why we have to say about, right? So the unit rate, how do you know? What did we do? I found this. What did we do? What math did we just do? What math did we just do in our equation box? Division. I found this by dividing the money by the hours. Because it says, how do you know? Okay. If it is not already there, could you show the unit rate in Doug's table? So we're going to zoom back up to Doug's table. Do we have our unit rate there? Did we find out how much it was for 1 hour for Doug? Did we find out how much it was for 1 hour for Doug? because that's unit rate is how much for one, right? In Doug's table, is there a 1 hour number? Yes. Okay. It's right here. Unit rate, right? Now, did we find out for Johnny how much can we see on Johnny's chart, on Johnny's graph, this 50 divided by 4? Yes, we can do that by making our line again, okay? But we're gonna make our line smaller, make it a 2, okay? If this is 4 hours, then this line must be 2 hours, and halfway must be 1 hour, right? So the first thing we're going to do is we're going to put our dot on the graph for this is 1 hour, and then this is 10, right? 10. So a little bit above that. Look at that. Right there on our graph. What do you know? Except I'm going to make it better. Okay, right there on our graph. And we're going to put our coordinates. So what would the coordinates for this one be? Let's draw the line in. I go straight down from my spot. Sometimes a little trickier than others. Come on, just go straight down. Thank you. And I go straight over from my spot. But I know what that number is because we figured it out, right? How many hours were we talking about? Parentheses. How many hours were we talking about? In this situation right here. How many hours? 1 hour. So that's X is 1. And how much money did he make in that 1 hour? How much money was he making in that 1 hour? 12.50, so 12.5. Close it. And I'm going to move it over closer to it. But I want it to show, so maybe I'll put it right here. Okay, so we see on Johnny's table the unit rate, the 1 hour for 12.50. We see on Doug's graph, on Doug's table, okay, Doug's table has the for 1 hour. Johnny's graph has the for 1 hour. So on Doug's table, what was the X we needed to use to find his unit rate? The X equaled what? Look again. What did we circle? The X equaled what? Because remember, this is my X. This is my Y. Okay, so for our unit rate, what did the X equal? For our unit rate, the one we circled, what did the X equal? For our unit rate, what did the X equal? We circled one. What was the X for the circle? One. X equals 1. Gives us his unit rate. On Johnny's graph, oops, that's a lowercase o. the point. What's the point? Which point on Johnny's graph told us the unit rate? So if we're looking at a graph, which point are we going to want to go look for? The one that goes parentheses what? What was his unit rate? What was the coordinate of his unit rate? Because on a graph, we need a coordinate. On a table, we can just go look for an X and figure out the Y. Yep. 1 comma, and we're going to go like this. So anytime you're on a table, you're looking for when the X is 1. Anytime we're on a graph, we're looking for the coordinate 1 comma something. Okay, so the table, X equals 1, look at that row. Let's put that in, X equals 1 row gives us his unit rate. But on a graph, the point 1 comma something gives us his unit rate. All right. So when we're looking at a table, we look for the row that has the X equal to 1. When we're looking at a graph, we're looking for the point that has 1 comma and a number. Okay. Oops, right, I did wrong thing. So for Doug, it was X equals 1 and Y equals 55 divided by 6. And then we're going to do this about. Because technically he was a 55 divided by 6. He wasn't a 9.17 because we had to round if we're being accurate. For Johnny, it was 1 comma 12.5. Okay, so on a graph, you're looking for the location where the X is 1 and what is the Y. And on the table, you're looking for the row where X is 1 and what is Y. Okay. Okay. So go turn in the assignment. It is done. We're going to talk about the homework assignment. And then, yes, we might actually get out of here a couple minutes.